Welcome to this brand new solution video of paper 5 970 Probability and Statistics 1 by Cambridge International. If you like this video, please share with with your friends and subscribe to my channel. Thank you very much. The question number 1. The random variable x takes the values -2, 2 and 3, just 3 of them. It is given that probability of the variable x when it is equal to x is this, where k is a constant. Okay, so what they mean is that if, let me write here, if the x is -2, yeah, this is the first value, -2, then its probability will be equal to k x square minus 1, and x in this case is -2. And if I evaluate this, it will become how much? 4 minus 1, 3k. The 3k is the probability of -2. Similarly, probability of 2 will be k 2 square minus 1, which is again 3k. And probability of 3 will be k 3 square minus 1, which is 9 minus 1, 8k. Right? Now, first we have to prepare a probability distribution table for x giving probabilities as fractions. That means k we cannot involve. So we have to evaluate k, and they said the variable x can take only these three values. That means their probabilities will add up to 1. So probability of -2 plus probability of 2 and probability of 3. These are the only three options, will be equal to 1. And this will help us to give the value of k. So 3k is the probability of -2, 3k is the probability of 2, and 8k is the probability of 3, which will be equal to 1. That becomes 6 plus 8, 14. And k will be equal to 1 over 14. We got it. Now we can draw a table. So x okay, the value of small x will write here, because we have just three of them, -2, 2 and 3. Probability of x equal to x. So when probability is -2, it is 3k. The probability is 3k, right? So probability of -2 will become 3 times k. K is 1 over 14. So it becomes 3 out of 14. So 3 over 14. Similarly, it is also 3k. So 3 over 14. It is 8k. 8 over 14. This is the table they are asking for. Okay. Let's see what is the next part. Find EX, expected value of x, and variance. Okay, so let's start with expected value. Expected value of x will be sigma x and px. Okay, so x is -2, 2 and 3, and px is their respective probabilities. So we'll multiply them individually, and sigma means add them. Okay, so that's what I'm going to do now. -2 is x, its probability is 3 over 14, plus, because of sigma, 2 is x, its probability is also 3 over 14, plus 3 times 8 over 14. These two are exactly same, with the negative here and positive here, they cancel out. So this becomes our answer, 24. Rather, let me cancel this. This will be 7. Sorry, this won't cancel like this. 8 and 14 will cancel out. So 4 and 7. So it will be 12 out of 7. And in decimals, if you want, did they say no? There's no need. So we can write in decimals also. 1 and 50 times 0.7 and you can write 1. 1.71 is the EX, expected value of X. What are variance? The formula for variance is sigma x square px, okay, is multiplying and subtracted by the square of the expected value. Okay, so in this case we have to square each x, minus 2, 2 and 3. So I will write here, I will square minus 2 and multiply by its probability. Then plus 2 square 3 out of 14 plus 3 square 8 out of 14, and then minus, and I will square this 12 over 7, not 1.71, because it is exact and it will help us to answer this one. So 12 over 7 square is the square of expected value. Alright, so 4 times 3, 12 over 14 plus 12 over 14, and this will be 9 times 8, 72 over 14, and there we have square of this 144 over 49. So 12 plus 12 is 24 plus 72 is 96 over 14 minus 144 over 49, which comes out to be 192 over 49, or in decimals it will be 3.91836. so I can write 3.92. So they have not specified what sort of answer we should write, so we can write this fraction as well as decimals. Question number 2. A 4-day long sporting event is starting on Sunday. The probability of raining on Sunday is 0.4, the first day. The probability on any subsequent day is 0.7 if it rained on the previous day, and 0.2, just 0.2 if it didn't rain on the previous day. Part A. Find the probability that it doesn't rain on any of the 4 days. So let me say that R means it rains and N means it doesn't rain. So on all 4 days it is not raining, that means it is N, N, N and N. So what is the probability of not raining on the first day, which is Sunday, is 0.4, no, 0.6. Why? Because probability of the rain is 0.4, so 1 minus 0.4 is 0.6 of not raining on the first day. Now, raining on the second day, if it did not rain on the previous day, is 0.2. That means not raining is 0.8. 1 minus 0.2. It did not rain, and next day it will be 0.8 again. Again it did not rain. So this will be the probability, first day, second, third and fourth. And if I multiply them, I get 192 over 625. In decimals it is 0.3072. We can write just 0.37307, 3 significant numbers. What about B part? Find the probability that the first day on which rains during the event is Tuesday. So it means that Sunday it did not rain, Monday it did not rain, Tuesday it rained, right? We are not concerned about what happened on Wednesday, right? Because what they're saying that the first day it is raining is on Tuesday, because it becomes a geometric probability. So not raining on first day is 0.6. Not raining on the second day is 0.8. Yeah, because it did not rain the previous day. And raining on the next day, if it did not rain on the previous day, is 0.2. And this is how we will get it. What 0.48, 0.096. Alright, the C part says find the probability that it rains on exactly one of the 4 days of the sporting event. So, what are the 4 options? That means rain on the first day, but no rain on next 3 days. No rain on the first day, raining on the second day, because they're saying exactly one day. So all the situations will be different. These are the 4 options. We will write their probabilities one by one, and it will happen either this or this or this, right? It will, all 4 cannot happen together, any 2 cannot happen together. So let's focus on this one. Raining on the Sunday is 0.4. Not raining on the next day will be 0.3. Not raining, because if it rained on the previous day, the rain on the next day is 0.7, but we do not want the rain, so it will be 0.3. Since it did not rain on the second day, the third day it will become 0.8 and again 0.8. We have to be very careful about writing this, okay? Not raining on the first day, 0.6. But raining on the second day, previous day it did not rain. So probability of raining on the next day is 0.2. Raining, right? Now it's not raining on the third day, but the previous day it rained. So if it rained previous day, the rain will be not raining, will be 0.3, and then it will be 0.8 because it did not rain on the previous day. Okay, now let's go to the first one. Again, it did not rain, so 0.6. Did not rain previous day, 0.8, and we don't want to rain, but we want it to rain here. So 0.2, it will rain, and next day it should not rain, so 0.3, because the probability of rain on a day if the previous day did not rain is 0.7. So not rain, because we don't want a rain, so 0.3. So let me write here also 0.6, 0.8, 0.8 and 0.2. While calculating, I get 0.0768 here, 0.0288, 0.0288, and 0.0768 again. And because they are independent events, so the sum will be 0.2112. This is the probability that it will rain exactly one of the 4 days. Question number 3. The following stem and leaf diagram represents the monthly salaries in dollars of 27 employees at each of the 2 companies. That means they are 27 here and they are 27 here. Okay. Find the median and interquartile range of the monthly salaries of employees in company A. Only this company we have to focus on. So let's find median because they are 27. So let's focus on median first. So median will be 27 plus 1 divided by 2, that position. So 28 divided by 2, 14th position from the least or the highest. 14th position will be the median. So let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. This is the median, and that comes out to be $2710, right? Because they have written here 227 and 1 is 2710. So this becomes the median. Let's talk about IQR now. So for IQR we need Q1 and Q3, lower quartile and upper quartile. Let's talk about the lower quartile. Lower quartile is the median of the lower half of the data excluding the median. So the 14th position, if I remove this 2710, remaining are 13 before this, right? The median of those 13 will be the Q1. So let's see what position will be the Q1. It will be 13 plus 1 divided by 2, which is 7th position. So 1, 2, 3, 4, 5, 6, 7. This is Q1, which is 2610 dollars, 2,610. Similarly, the 7th position in upper half excluding median will be the upper quartile Q3. So let me count from backwards, because it is cleaner from backwards. Otherwise you can count from here. Okay, let's see from here also. 1, 2, 3, 4, 5, 6, 7. This becomes Q3. If I count from backwards, 1, 2, 3, 4, 5, 6, 7. Again it comes out to be the Q3, which is 2840. So because we were about to find IQR, IQR is Q3 minus Q1. So in this case Q3 is 2840 minus Q1 is 2610, which comes out to be dollars, how much? 230. That's the interquartile range. Okay, let's go to the second part, the lower quartile. Okay, let me make it a little visible little. Okay, the lower quartile Q1, median and upper quartile Q3 for company B. We found for company A, so for them it is 2600. Upper quartile Q3 is 2780, and median is 2690. What do we need to do? Draw two box and whisker plots on a single diagram for both companies A and B, and the space is given here. So what will I do now? I will fasten up this video, and you will see how I do it. So after a lot of struggle, I was able to draw this box and whisker diagram. So this is for company A, this is for company B, and my software has some problems. That's why these boxes came out. I don't know how, but this is how the box and whiskers will look like for the two companies. Okay, so let's see what is C. Comment whether the mean will be a more appropriate measure than the median for comparing the two companies' salaries of 27 employees. Okay, so since we see here that the minimum of company B is higher than the minimum of company A, maximum is also higher for company B, but you can see that the median is lower than the median of company A, opposite of what is happening for median and mean, or maximum and minimum. So, and company B, the data is more spread out. However, most of the employees had lower salaries because its median is on lower side. So yes, it will be a good decision to compare their means rather than box and whisker plots. So that's what I'm going to write here under this box and whisker plot. That's it. Question number 4. A fair 5-sided spinner has sides labeled as 1, 2, 3, 4, 5. So it's 5-sided, 5 numbers, and it's fair. Fair means each one has same probability of 1 out of 5. That's the probability of each one of them. Okay. The spinner is spun until a 2 is obtained. That means it's a geometric probability on the side on which the spinner lands. The random variable x denotes the number of spins required to obtain 2, right? So 2 is the success here. Success is getting a 2. So failure will be not getting a 2. So probability of success, which is P, will be 1 out of 5. Probability of failure, which is Q, will be 4 out of 5. 1 minus 1/5 will be 4/5. So we got it. And now we want the probability that we get a success on the 4th trial. That means we fail first time, which is 4/5. We fail second time. We fail third time. But for sure we get a success on the 4th attempt, and that's what the answer will be. 4 times 4 times 4, 64 out of 25, 625. This is the answer. You can convert it to decimal, but it will be a very small number, so it's better to leave it as a fraction. Part B. Find probability that success is within first 5 attempts, because it's less than 6, not equal to. That means success is before the 6th attempt. But which attempt, we are not sure, right? But what we are sure, that we do not fail for consecutive 5 times. We don't fail. So don't fail, we subtract it from 1, and failing all 5 times is q to the power 5. So this is how we interpret this one, which will be 1 minus failure is 4/5, right? Yeah, 4/5 to the power 5, which is 1 minus 4 to the power 5 will be 2, no, not 256, 1024 over 5 to the power 3125, which will be how much? 2101 over 3125. This is the probability, and if you want to convert this to decimals, which will be divided by 3125, 0.6723, so 0.672 you can write as 3 significant figures. Going to this next part, which is 2 fair, again fair, 5-sided die spinners, each with size 1, 2, 3, 4, 5 again, are spun at the same time. If the numbers obtained are equal, the score is 0. Otherwise, the score is the higher number minus the lower number. Find the probability that the score is greater than 0, given that the score is not 2. Okay. Obviously, we'll get mostly positive answers, because higher number minus lower number will give us a positive number. So let's see, let's form a table and see what do we get. Okay, 1, 2, 3, 4, 5 from the first spinner, 1, 2, 3, 4, 5 from the second spinner. When the scores are same, we get a 0. So 1 and 1, if both of them give you 1, you get a 0. 2 and 2 will give you 0. 3 and 3, 4 and 4, 5 and 5. Now 2 minus 1, higher minus lower, is 1, 2, 3, 4. 2 minus 1 will be 1. 3 minus 2 will be 1. 4 minus 2, 3. 2, 1, 1, 2. Similarly, 4 minus 1 is 3, 2, 1 1, and here will be 4 3 2 1. Okay, we got our table. Total there are 25 possibilities. Okay, and now we can make a table out of this if we want. Let's make a probability distribution table. So what is the smallest score we are getting? 0, right? Then we are getting 1, then we are getting 2 as well, 3 and 4. 4 is the highest score we are getting. Okay, what is the, okay, this is the score and this will be the probability. So zeros, 1 2 3 4 5 zeros out of 25. And let me not simplify it to 1 over 5 because it will help in calculations later. 1 2 3 4 5 6 and 7 8. 2 1 2 3 4 5 6. 3's 1 2 3 4. 4 1 and 2. That's it. There is no one which is not circled. So 2 out of 25, and their sum should be 1. 25 out of 25. So 5 plus 8 is 13, 19, 23, 25 done. This is the probability. Okay. Find the probability that the score is greater than 0. That let's call it x. Okay, greater than 0. Given that score is not equal to, it is not equal to 2. Okay, so if you remember, our formula for conditional probability is that P A given B is equal to P A intersection B divided by probability of B. Okay, so first of all, we'll see the cases where these both cases are there. That's what intersection means. So probability of x is greater than 0, intersection x is not equal to 2. Their common scores, and then probability that x is not equal to 2. X is not equal to 2. Let me write here. Not 2. That means this is not the case. Then 6 over 25 will be subtracted from total 1. 1 over 6 over 25. We got our denominator. Now the cases where it is more than 0 and x is not equal to will be these three. 1, 2, 3. These three cases are the ones where it is greater than 2. Score is 1, 3 and 4 are greater than 0, and all three of them are not equal to 2 as well. So we will write here 8 over 25 plus 4 over 25 plus 2 out of 25. So 8 plus 4 is 12 plus 2 is 14 out of 25 over 1 minus 6 over 25 will be 19 over 60, 19 over 25. So 25 and 25 will cancel. Final answer is 14 out of 19. Alright, let's go to question number D part of the same question rather. The two spinners are spun at the same time repeatedly again. Alright, for 9 randomly chosen spins, 9, total 9. Find the probability that the score is greater than 2 on at least 3 occasions. At least 3 occasions. Okay, greater than 2. So the success here in this case is being x is greater than 2. Okay, that means not 2, more than 2, which means 3 and 4. Okay, so let's see what is the probability of getting a 3 and 4. 3 is 4 out of 25, 4 is 2 out of 25, total 6 out of 25. So the probability of success P will be 6 out of 25. That means the failure will be 1 minus 6 out of 25, which is 19 out of 25. Alright, got it. Now we want at least 3 occasions. It becomes binomial probability. Why? Because the probability of the success remains same, failure remains same, there are fixed number of attempts, right? And they are independent outcomes every time. So yeah, we can use binomial. So at least 3 means probability of getting a 3, x equal to 3, or getting a 4, or getting a 5, or getting a 6, 7 and 9 up to 9. So it is too much, right? So many of them are to be added. We can otherwise do this: 1 minus probability of the ones which are not part of this list. Probability that x is 0 or 1 or 2. These 3 are missing from the list. We will subtract them from 1 and we'll get our answer. So 1 minus probability of 0 will be 9c0. Probability of success is 0. Success probability is 6 over 25 to the power 0. But 19 out of 25, the failure, all of them are failure. So 0 plus 9 should be equal to this. So it's 9. That's the probability that success is 0. Then next will be 9c1. Success is 1. Failures, you guessed it right, 8. 1 plus 8, 9. And then we'll have 9c2. Successes 2. Failures 7. That's it. Just carefully put this in a calculator and we'll get the answer. Let me do them one by one. What I got for this is 0.0846. I would recommend that you do it yourself. I am answering this paper without a mark scheme, so if I made a mistake in using calculators, you will not be. So it's better you do it yourself. I've tried my best. This is what I'm getting. So it will be 1 minus 0.6287. I have rounded off all the digits to 4 decimal places. So 6287, which is 0.3713. And if you want 3 decimal places or 3 significant figures, it will be 371. 0.371 is the probability that you will get greater than 2 result on at least 3 occasions. Question 5. The lengths of western bluebirds are normally distributed with mean 16.5 centimeters and standard deviation 0.6. A random sample of 150 birds is selected. A. How many of these 150 birds would you expect to be a length? How many? Okay, not probability. How many will expect to be a length between 15.4 and 16.8 centimeters. So let's try to visualize this. So if this is normal distribution and the mean is 16.5, we want to see how many are between 15.4. So 15.4 I'm assuming is here, and 16.8 will be closer to 16.5. This area we have to find. Okay, so my plan would be that I will find how many or what percentage will we have under 16.8, right? So the formula for that is, first we need to find z score. Z score will be x minus x bar over sigma, where x is the given length 16.8 minus the mean length, which is 16.5, divided by sigma, which is 0.6. This will be the z score of this one. Then I'll find probability for this, which will be less than 16.8. Then I'll find probability for less than 15.4. Okay, so if I find this from 16.8, this area, then I will find this area less than 15.4, and if I subtract this from this, I'll get the remaining area, which is between 15.4 and 16.5. That is the question, right? So let's focus on this one. I'm finding Z score for this. So Z score will be 0.3. Oh, that's straightforward. 0.6. So it is 0.5. This is the Z score. So probability that Z score is less than 0.5 will be how much? Let me have a look at the table I have here. 0.5 is here, 0.6915. That is the probability. So 0.6915. This is 0.6915. Now I have to find this probability less than 15.4. However, we can see that 15.4 is less than mean. That means the Z score here will be negative. So we have to keep in mind that it will be negative. So Z for this will be 15.4, which is X, minus, again mean is 16.5, divided by 0.6. So that will be negative 1.1 over 0.6. That comes out to be 1.8 triple, rather 83, and that is going on 1.8333. Okay, so I'll go to my table again and see what is the probability for 1.8333, and I'm ignoring negative because I'll take care of that later. So here it is. 1.83 is this 0.9664, and next 3 is 2 on the same line. So 0.9664, and we'll add 2 to this, so it becomes 0.9666. 2 is added to the last digit only, so 0.9666. But we will write probability that Z is less than negative 1.83 will be, we can't write 0.966 straight away because it's negative. In case of negative, we will write 1 minus 0.9666. That's how we take care of the negative sign, which will be 0.0334. Okay, so now we have to find the probability of X between 15.4 and 16.8, and for that we'll subtract 0.6915 minus 0.0334. Answer is 0. How much? 1, 8, 5, 6. But they ask how many of these birds will we expect to have this length. So how many is the number we want, and if want that, for that we had number of birds from 15.4 till 16.8 will be NP, the total numbers and the probability they have. So 150 was the total number multiplied by probability 0.6581, which comes out to be 98.715. And since I have rounded off most of them, so I can't give this as a number. So 99 birds are expected to have a length between 15.4 centimeters and 16.8. Next one, the length of eastern bluebird. This was western bluebird. The earlier one was western. This is eastern. So that means it is a different scenario here. They are normally distributed again. So let's draw it again. Mean is 18.4, so they are longer in length. Okay, and standard deviation is sigma. We don't know it. It is known that 72% of them have a length greater than 17.1. So let's say 17.1 is here. That means this one is 0.72, this area. That means this area is remaining 0.28. Yeah? Okay. Find sigma. So we already know that Z score is the data minus mean data divided by sigma. Sigma we have to find out. X we know. X is how much? 17.1 minus mean is 18.4 over sigma is unknown and Z score is unknown. But what we can do, that we can convert 0.72 into Z score, but we know that this table we look at here, this table is always less than, if there is a graph, less than area is 0.72, not more than, like we have in our question. So we'll take care of this just like we did earlier. So let's see, 0.72 is what Z score. 0.7190 is this one, so it becomes 0.58. 0.5 is here and 8 is here. That's why it is 0.7190. And to make it 0.72, we need 10 more. So this is 10. That means next digit will be 3. 0.583 is the Z score of this one. Okay, the one which is a reflection of 17 point on this side, which that will be 0.583. But because 17.1 is lesser than mean, we will write minus 0.583. That's how we did in previous part also. If you remember, look here, this was negative, so that's why we wrote 1 minus this because of Z score. So here, whatever is the Z score of this, let me tell you how much is that. It is 1.3 lesser, so this will be 1.3 more, 19.7. Actually 0.72 is the probability less than 19.7, for which we got Z score 0.583, and but we want for 17.1, so we got it negative 0.583 for 17.1. Okay, and now we'll find sigma because we know everything. So sigma comes here, and our negative 0.583 will go as denominator there, and simply we will divide this. Using our calculator, we get sigma equal to 2.2922984, which we can round off to 2.23. All right, next one, a random sample of 120 eastern bluebird. So eastern bluebirds are the ones which are in this part, eastern bluebird, okay, is chosen. Use an approximation. So we know only one approximation, which is normal approximation, to find the probability that the fewer than 80 of these 120 bluebirds have length greater than 17.1. The earlier one was greater than 17.1, again the same thing. Okay, that means the probability is equal to 0.72. yeah, that's what they gave us. Length greater than 17.1 is 0.72. all right, okay, so what we want, fewer than 80. So let's do normal approximation again. So first we need a mean, and mean is n times p in normal approximation, which is n is how many, 120 times 0.72 is the probability, so it comes out to be 86.4. okay, so our mean becomes 86.4, mean number of birds whose length will be greater than 17.1. We want 80 and fewer than 80. This we want. So again we'll find the Z score. 80 actually not 80, because question is fewer than 80. That means 80 is not part of it. Fewer than 80 means 79 and below, right? And since this is discrete data, to make it closer, we will use 79.5 as X. So if I find Z score for 79.5, it will be 79 and below. So that's how I will write here 79.5 minus what is 86.4 over standard deviation, and standard deviation we don't know. Let's find standard deviation, which is square root NPQ. Square root NPQ will be 120 times P was 0.72. Q will be 1 minus 0.72. The probability of failure of not finding greater than 17.1 centimeter will be 0.28. So 0.28. If I use my calculator, I get 4.918536 something. I can round it out to 4.92. 3 significant figures, and that's what I will use here. So the Z score will be negative 1.4024. So I will write negative 1.402, and rightly so, because it is on the left side, less than mean, it has to be a negative Z score. So probability of Z less than negative 1.402, since the Z score is negative, again we will write 1 minus and the Z score of 1.402. let's see on table what it gives us. 1.402. 1.40 is 9192, and 2 will be this. I hope this is 2 only. Yeah. So 3. So it will become 0.9195. Okay. 0.9195, and if we subtract that, it will be 508 0.0805. 3 significant figures are okay. This will be the probability that fewer than 80 of selected 120 eastern bluebirds will have a length greater than 17.1 centimeter. Number 6. In a group of 25 people, there are 6 swimmers, 8 cyclists, and 14 runners. 14 plus 11, 25. Okay. Each person competes in only one sport. The team of 7 is selected from these 25. Find the number of different ways in which the team of 7 can be selected if it consists exactly one swimmer. So let's say swimmer is 1, at least 4 cyclists. Okay, at least 4. So let's go to at least 4, and at most 2 runners. So runners, let's make it this 0. Okay, is it becoming to be 7? No. That means we have to we can't change swimmers because it is exactly one swimmer, right? We can't change it. That means I'll have to make it 7. I'll have to write 2 runners here. Now it becomes 7, right? Now if I keep swimmer 1 but I increase the cyclist to 5, do we have cyclists? Yeah, we have 8 cyclists. So 1 plus 5 is 6. So there will be 1 runner. Again, 1 swimmer, I increase it to 6. So there will be no runner, and this fulfills all the possibilities, right? We can't change this. We have already looked at this one. So now we will interpret them into how many ways it can be done. So swimmers are 6. So out of 6 swimmers we have to select 1 here. Out of 8 cyclists we have to select 4 of them, and out of 11 runners we have to select 2, right? This is one combination. Or whenever we say either this will happen or this will happen, we add them. So again it becomes 6c1 times 8c5 this time, and 11c1, and 6c1 times 8c6 times 11c0. Okay, and now we will evaluate them and add. And these are the numbers I get, and since they are OR, we'll have to add them, and after adding them we get 964. Moving on. For another competition, a team of 9 people consisting of 2 swimmers, 3 cyclists and 4 runners is selected. Okay, so 2, 3 and 4, total 9 are selected. Okay, the team members stand in a line for a photograph. Okay, how many different arrangements are there for 9 people if the swimmers stand together, cyclists stand together and runners stand together? So okay, not a big deal. This is the easiest thing we can have. So there are 2 swimmers, both of them stand together, so we put them in a box and they move together. Then we have 3 cyclists and then we have 4 runners. They are standing together, so they can change their place by 3 factorial ways. But within this box, these 2 can change their place, other 3 can change their place, and 4 can change their place. Just multiply this and you get your answer. 6 times 2 is 12, 12 times 6 72, and times 24 will be 1728 is the number of different arrangements possible. Alright, C part. How many different arrangements are there of 9 people if none of the cyclists stand together to each other? So how many cyclists were there? 4 runners, 2 swimmers, 3 cyclists. They are not together. Okay. So we have total 9 people, right? 3 of the cyclists, we don't want them to stand together. So how many people left now? 1, 2, 3, 4, 5, 6 people left now, which are swimmers and runners, right? So these 6 people will focus on, they can change their place in 6 factorial ways, correct? Now these 3 cyclists have to choose these places so that they are not together. How many places are these? There are 7 places. 1, 2, 3, 4, 5, 6, 7 denoted by these circles. These 3 cyclists will take any 3 positions out of these 7. So we will write 7P3. P because their arrangement matters, the way they stand. So they will take any 3 of these places and we'll ensure that there is someone between them, they are not next to each other. Just do this and you get your answer, which comes out to be 151,200 arrangements. 151,200 arrangements are possible by this way. This concludes our solution video. I hope you liked it. If you did, please give it a thumbs up, share with your friends. I've seen that no one else has answered this paper yet, and it takes a lot of efforts to prepare these videos. So please subscribe to my channel to get such videos in future too. Thank you so much.